Hello everybody, my dear friends, my dear students. We continue our object-oriented programming with C++ course. Today's lesson is very important, maybe the most important. Lesson number 3. We are going to cover a lot of essential terminology. Don't forget to support my channel, give me some likes. Share videos with your friends, subscribe. So briefly, in lesson number 2, we tried to apply object-oriented concepts to just regular C. C doesn't have OOP features. However, OOP ideas are wider than any particular language. And we created class in two files. In one file, header file, we declared data members, we declared functions prototypes. In the second file, with the same name but with the extension C, we implemented all our member functions. And if you remember, all the member functions, they needed as a first parameter the address of the object they working on. Now we are moving to C++ and we are going to create rectangle class. We are going to implement rectangle class member functions. And we are going to cover, as I told you, many essential terms: classes, objects, developers and users, instantiation, constructors, data members, member functions, instance variables, encapsulation or data hiding, getters, setters, keyword this. Okay, so we create classes in C++ in two files. You see rectangle.h file where you declare data members, variables, and member functions, prototypes, just the prototypes. And also you have a second file with the same name, rectangle but extension CPP, where you show the implementation of the member functions. So in many books, in order to maybe save paper or the author is trying to make discussion simpler, they combine class declaration and member functions implementation in one file. It is possible, however, I don't recommend this approach. It's kind of similar to Java. In Java, yes, classes declared and implemented in one file. However, C++, much more natural way to do OOP is two files. Header file, just the data members, just the prototypes, and C++ file is member functions implementation. And by the way, if you using, for example, Visual Studio, and if you're trying to add a new class to your project, it's going to generate two files. Visual Studio will generate a header file and C++ file. Okay, so rectangle class has three data members: width, height, and outline. It has the grow, shrink, and draw functions, but you see something new. We have two constructors. Constructor is a special function to prepare your object. Let's emphasize, class is a template, an idea. But object is something real you create later on based on that template. So constructor is a special method to create objects, to instantiate objects. And in the previous lesson, by the way, we created something like constructor, and we called it build. But now we follow C++ rules, and the constructor name must be the same as the name of the class. Second rule, constructor must not have any returned values. Also, as you see, you may declare many constructors. They should have just different signature, different parameters list. What else? What is different comparing to the previous lesson? You see access modifiers. So in object-oriented programming, you can declare certain members as private, certain members as public, and that means that you restrict access to the members. You restrict access for users of your class. So when we discuss OOP, and it is very important point, we always change our perspective. Sometimes we are talking about OOP from the class developer point of view, from the programmer who actually creates those two files, rectangle.h or rectangle.cpp. But sometimes we change the point of view and we're talking about instantiation, about using, and they called objects, the variables of new type. So this is class, but this is object, and creating objects is called instantiation. So what I'm trying to emphasize is when we're talking about OOP, always be aware there are two different perspectives on the subject. Yes, of course, sometimes class developer is a class user. Yes, the same programmer may do both, but most of the time in professional development, it's different. Certain programmers develop classes, certain programmers use them. So when we say class, it's about developers. When we say object, it's about class users. So private members can be accessed only by developers of the class, but they cannot be accessed by the users of the class. Public members available for both. So developer, by using private and public keywords, somehow restricts. He restricts access to class member for class users. For example, right now, all three data members are private. Some functions also private because the user of the class not really interested how I did the drawing function. He needs just to draw, but the details, technical implementations, because draw function developed in 3 steps, it's not really interested for the user. So that's why those technical functions declared as private. Now, let's take a look at the implementation file. Now you see all the member functions supposed to have prefix, rectangle, and double column. You see how I did 2 constructors. Constructors basically are to initiate data members of the object. So constructors are to bring the object into the valid, ready-to-use state. You see how I did grow, how I did shrink, very similarly to the lesson 2. You see how I did draw. I just called those 3 technical functions, which I made private. So this is member functions implementation, and we are looking at the class from class developer point of view. Let's talk about constructors. They are very important because they are called when the object is created. And when you initialize member or data members of the class in the constructor, you see there are 2 different ways to do that. This is kind of confusing point for the beginners. So I could initialize my data members just in the body of my constructor. So that's possible, nothing wrong. So one constructor creates 3 by 3 rectangle with the asterisk, but second constructor creates any kind of rectangles with any characters. So what I am trying to explain, yes, you can initialize members in the body of the constructor, but also C++ gives you a second way to achieve the same goal, and it's called initialization list. It's up to you which method to use, but sometimes in certain situations you can do initialization only in the body. Sometimes you can do initialization only through the list. It depends. So right now I do initialization through the body of my constructor. And now let's move the point of view. Now I'm not a developer. I'm a user of the class. And what I'm going to do, I'm going to instantiate, I'm going to create variables of new type, because class is a new custom type. So you see line 11, first instance, first object created. Because it doesn't have parentheses, that means the first constructor is called. Constructor without parameters, sometimes we call it default constructor. Line 12, we create another instance or object of rectangle class R2, and now it's 4 by 4, and the outline character is minus. Then we call draw, grow, and draw on first object. We try to do draw, shrink, and draw on the second object, line 16 to 18. And finally, in line 19, I demonstrate that objects can be created not only on stack, as we did in line 11, 12, but also you can create objects on dynamic memory. We call it heap sometimes. And in Classic C, we don't have keyword new and delete. You allocate memory in Classic C using malloc library function and free library function. Anyway, line 19, I created rectangle dynamically on the heap, and then I have the address of the rectangle. Because it's address, it's a pointer, I don't use dot to access member functions. I use arrow operator to access member functions and data members as well. So let's try to test this small program, what you see right now. By the way, this is important. If you use objects on a heap, you have to delete the memory before you finish your program. So it's like malloc in C and free function in C. If you don't do delete, it's called memory leakage. You borrow RAM, but you don't return it back to the operating system. I changed a little bit my batch file comparing to lesson 2. Now it's not GCC compiler, it's G++ compiler. Now I can call my console. I can go to my desktop. I can go to my folder. I can call my batch. No error messages. I can call the executable. Let's wait what happens. And here we are. This first rectangle was created with default constructor. Second rectangle was created with the, let's double check. Oh no, so the first rectangle we created with default constructor, that's true, but then we did grow. You see the second rectangle is bigger because we grow on both X and Y. After that, we created a rectangle using second constructor. So it's 4 by 4, it's a dash. Then we tried shrink, look, shrink method. By the way, member functions in many programmer languages, they are called methods. But in C++, we call them member functions. And finally, what you see below, it's the rectangle created on the heap. And we did the draw and we deleted that rectangle. Now, let's talk about encapsulation or data hiding. Oh, by the way, let me demonstrate. It's important, guys, to know that you can write constructors in 2 different ways. So you could also use in your constructor initialization list. It is possible. And again, which technique to apply depends on your concrete situation. Right now, they're both good. So let me show you, it's going to work the same way. I changed a little bit my constructor. You see no error messages. You see the same result. So, encapsulation, what it's about? It's about hiding data members. So it's a recommendation to keep data members private. Which means if I'm trying to access my data members as a user, not as a developer. Developer can do anything. For developers, private or public, they don't really matter. Developer can see everything. But if I'm trying to access my class data member, sometimes we call it instance variable. Look, I'm trying to print first rectangle width. If I'm trying to do that, let's try to recompile. What you see is error message. You're not allowed to use this data member, and the approach we discussed is called encapsulation. So it is recommended to keep data members private. Why, by the way? Because if you open data members, if you make them public, the user of your class may damage your class just because he doesn't know exactly the structure of your class, the rules your class supposed to follow. Just because of the lack of the knowledge, he may inadvertently damage data members. So the encapsulation rule or the encapsulation recommendation is keep them private. But if the class users need somehow to access them, provide safe functions, and they may validate access. They may, because functions definitely smarter than data members. So if you access data members through the functions, you may not damage data members, and sometimes we call those special functions to access data members, getters and setters. But please be advised, encapsulation rules are not iron-made rules. It's all up to you, all up to developer to keep your members the way you feel, because the disadvantage of encapsulation, when you keep all the data private, when you provide getters and setters, the disadvantage is quite obvious. It's less efficient. You don't access members directly. You call the functions. Any function, it's a stack, it's a call, it's return. So sometimes you may just say, well, that's fine. I don't mind, guys, if you access my members. This way, I can print. Let me show you what I did. I opened access to the data members, and now I can see. I see number 3, so that's now allowed. This is allowed. So what I'm saying is, if you open your data members, if they are available for the users of your class, then please talk to them, explain them. Sometimes it's much better, instead of making your class heavier, less efficient, overloaded with the member functions. It's sometimes easier just to talk to your friends, the programmers who are going to use it, and explain them what they may do with the data members and what they're not supposed to do. But as a general rule, and we call it encapsulation, it is not recommended. So I can show you the diagram. So encapsulation rule is to hide data members and to allow access to them through special member functions. You see the picture. Data members are hidden in the inner circle, and member functions are located outside. Okay, that's good. A lot of basic terminology we covered, but an interesting question. When I see my member functions, For example, grow. When I increment the width and the height of the rectangle, the question is which one my grow function now is processing. How? So the question, how my member function knows which rectangle to grow, because there are many rectangles. Well, you don't call member function just as we did in the previous lesson in procedural C. You call always member functions with the object name. So implicitly, always the address of the object is passed to the member function. And member function always knows which one to operate on. Sometimes, if you want to make it explicit, you can say this. So this is the address of the object which called the member function. So yes, it is possible to reveal the mystery and to say get the object address, and on that object increment the width and increment the height. So this is also valid code. Let me prove it. You should know about this keyword. It's quite important because usually, let's say most of the time we don't need it, but however, sometimes you will see it later on in certain situations. I need to know the address of the object my member function was called with. But again, let me show you. This is good. Let me compile. No error messages. Let me call. And I see everything is fine. Everything is working the way it worked before. So let's wrap it up. A lot of stuff we did today. We talked about classes and objects, about class developers and class users, about instantiation, special member functions to instantiate. We call them constructors. Sometimes we have many constructors in the same class. It's absolutely normal. Constructors must have the same name as the class. They don't have returned values. We discussed data members and member functions. By the way, sometimes we call data members instance variables. But again, this difference is about your perspective. So if you're talking about developing class, you may call it data members. But if you're talking about class user, we call them instance variables, variables that belong to a particular instance or object. We discussed encapsulation or data hiding paradigm concept. We mentioned special member functions to access hidden members. We call them getters and setters. We discussed keyword this. It allows us to access the address of the current object. You don't have to use it if you don't need it, but sometimes in certain situations you need this keyword. And that's basically the overview of the lesson number 3. Again, let me show you the class. By the way, we can also hide not only data members, we can hide certain member functions if you believe they not really interesting to the class users. So this is again the implementation to constructors. Important point, there are two different techniques to initialize data members in the body of the constructor or in the initialization list. Again, it depends on your situation. Right now, they both good. Both ways are good. So let's again review how member functions are implemented. Any member function is supposed to have prefix with the name of the class and double column. And this is 3 private functions because they are too technical. Draw top, draw middle, draw bottom. They are too technical to be revealed for the class user. Thank you very much for listening. Please share my videos with your friends, promote my channel, and we are going to discuss in the next lesson very important topic, static class members. All the best to you guys. Bye-bye.